Oh, hello. Today we're going to be discussing something called factoring, which is the reverse of foiling. Last week we did some foiling, and let's just review a little foiling. Suppose we have this. 5x minus 7 times 2x minus 3. Okay. And thinking about what's different here. We did foiling last time. Yeah, okay, just humorous. If I start foiling out, 5x times 2x is 10x squared. First, outer, 5x times a negative 3 is a negative 15x. Inner, negative 7 times 2x, is that a negative 14x? What about the last two? Negative 7 times negative 3 is positive 21. So let me go ahead and label FOIL right here. First, outer, inner, last. Which of those can we combine? The outer and inner, we can combine those. So here's what we would say the final answer is. 10x squared, I'm just carrying that down. And then combining negative 15x and negative 14x. Negative 15 plus negative 14, that's a negative 29x. And then plus 21. So this first term, we got that from multiplying the first two terms here. This last term, the 21, that's the negative 7 times negative 3. This middle term, that's the outer and inner terms combined together. Can you see that? The pink? Okay. Well, let's do another one. How about 7x plus 9 times 2x minus 5. Foil that out with me. Let's see. What will we have? The first terms. 7x times 2x, 14x squared. Remember when we were working with those imaginary numbers, we got I times I squared? We're not doing that here. It's just x. So we have 14x squared. Then outer would be minus 35x. Inner, is that a positive 18x? So I went first, outer, inner, I'm up to the last. Positive 9 times negative 5, negative 45. So first, outer, inner, last. I'll combine like terms. There's nothing I can combine with the 14x squared. What about the outer and inner here? Can I combine them like I did up here? Yeah, negative 35 plus positive 18. What's that going to be? Negative 17. Good. X. And then we still have that minus 45. Well, what we're going to be doing today is going backwards. Given this is called a trinomial. There are 3 terms. 1, 2, 3. How would we go back to these 2 sets of parentheses? Okay, so that's what we're doing today. And if you took Developmental Math 371, that's the last 6 weeks of the course. Except you do a lot more factoring, different types of stuff, but all we're going to be looking at today are what's called factoring trinomials, and we're going to be using a reverse FOIL because we're going backwards, or sometimes called trial and error. Okay. Now, when I look, keep it in mind, we're going to be going backwards. Given this, come up with the two sets of parentheses. So your answers are going to have two sets of parentheses today. Well, if I'm going to assume that this first number here is always positive. Okay? So I'm going to write out a table to help you begin to factor something in the form ax squared plus or minus bx plus or minus c. I'm going to assume this first number is always positive. If it's not always positive, if it's not positive, we'll make it positive. It's a sensible assumption that this number A is a positive number. Okay.
Also, this thing has three terms, so it's referred to as a trinomial.
Mm-hmm.
So we're factoring trinomials today. Polynomial expressions with three terms.
1, 2, 3. And I'm going to make a table that, I don't want to word it.
It'll make sense after you master factor.
It'll make sense. Yeah, the table will make sense once you know how to factor. And that's how you'll know, oh, I know how to factor. This table of theirs makes sense. Okay? So, I'm going to have, 4 columns in this table?
Yeah.
Mm-hmm. Sorry. Second column is going to say factored form. Mm-hmm. Fill in.
And that fill-in phrase will make sense eventually.
To get middle term from O and I.
That symbol in front of the I there
Is
says
and. Okay. Like right up here on both of these, the middle term you get by combining the outer and inner term. Okay. Like right here, the middle term was a negative 17x. How did we get it? We combined the outer and inner term. If you needed two numbers that multiply together to give a positive number, what sort of numbers multiply together to give a positive number?
I'll get us started. One option is positive times positive. That's positive. What's
What
the
else?
other one?
Negative times negative. I'm going to talk about first sign and second sign. And you may say, well, wait, what if this A is negative and then there's 3 signs? No. A is going to be positive. That's a good assumption. So this is the first sign. This is the second sign over here. If the second sign is positive, that would be like right here. Again, we're going backwards. The last 2 terms have to multiply together to give this this number right here, the positive 21. So what numbers multiply together to give a positive? Well, either positive times positive or negative times negative. Why? Well, we know the answer is negative. How do you know that here? By looking at this sign. If the second sign is positive, you have 2 of the first sign in your factored form. If we were trying to go backwards, again, this is what we're trying to find. So if we have 10x squared minus 29x plus 21, I can look at that and say, okay, second sign is positive, so 2 of the first sign.
Inside the parentheses, move your finger. Minus
and minus. So that's what I'm telling you how to find that. Okay? Now, what sort of numbers multiply together to give a negative number? A negative and a positive. So if the second sign is minus.
Maybe instead of saying second, you should say last sign.
Okay.
Because that's the last sign in the trinomial.
But if it isn't. Okay. But if there's a sign here, then it's not going to work out anyway. Saying like or whatever. Okay. So if the second sign or the last sign is a minus, then what did you say? What sort of numbers multiply together to give?
A negative and a positive.
Okay, so there's 1 plus and 1 minus in the parentheses. Like right here, if we're going backwards, that 45 has a minus in front of it, so that means there's a plus and a minus in here. Now the third column is just a preference of mine. I don't even know if I've convinced him of it yet, but that's just how I like to do it. If the second sign is plus, then I like to fill in the signs immediately, because second sign is plus, 2 of the first sign. You know it's minus and minus. Second sign is minus, then the factored form has 1 plus and 1 minus. I wait to fill those in because I don't know where the plus goes. Does it go in the first set of parentheses or in the second? And this last column. Again, the table will make sense once you know how to do this. Okay? So, and I'm saying that sort of jokingly, but it's sort of true too. Okay? If we look up here, the way we combine the outer and inner to get this middle term, ignore the signs.
You've already taken care of the signs with that.
With all of this.
Yes, okay.
15 and 14. What am I doing to the 15 and 14 to get that 29? Am I adding them or subtracting them? Ignore the negatives. To go 15, 14, 29, what am I doing to those two numbers?
Adding them.
Adding them, okay. And down here, 35 and 17. Ignore the
35
sign.
and 18.
35 and 18. What am I doing to the 35 and 18 to get a 17? Adding or subtract? Subtract. Before this seems too helpless or hopeless, let's do the first problem, Tim. Okay?
Oh. Okay, so have I already opened it? I don't think I have.
Oh, wait,
we have it set here at the beginning, so y'all have to. I wonder if you see Tony's always covering up stuff.
Oh, that was January 24th, 2024. Okay, let's close that out.
You got to click on them, even if you don't watch them. You got to click on them.
That means if you're going to work ahead, or if you're not going to show up, you can just watch those. You don't have to wait for the video to be posted to YouTube.
And I saw some people working ahead. I don't want it to seem like I'm stalking or anything. I was just looking through the grade book, and I'm assuming the people that were working ahead that have already done this, they probably watched one or both of those factoring assignments, or else they already knew how to factor from previous math courses. But this is an important topic, and even though it's covered in Math 371, I think it is an excellent use of our time.
Oh gosh, is that a V?
V for victory.
8V plus 5.
If I ruled the world, I don't suppose I've told you all this, but if I ruled the world, that's one of the laws that I would make, my first day in office. I'd outlaw variables other than things like, I'd list the ones that are acceptable. X is acceptable. I think W is acceptable, okay? I'd outlaw the use of the variables that have tails. I hate a Y because the tail on the Y goes on the line underneath and interferes with what you're writing beneath it. But,
I don't think we should use S's because S's look like 5s.
Fives, yes.
I discovered my first
T's.
10 years of
T
teaching.
as a variable, it becomes
Why are
pluses.
students missing this problem? Oh, wow. put an S in the problem or a T, half the students that would get it right normally miss it. The S becomes a 5 and the T becomes a plus. So, now, we're going backwards now. Our answer here is going to be 2 sets of parentheses. Let me go ahead and write out those 2 sets of parentheses.
Because you're going to be able to fill in something very quickly.
Now, looking at this table doesn't make any sense to you at this point. This is the first sign, and here's the second sign.
Keep in mind that first sign is the one that's on the variable term without the exponent. For this process to work, you have to have the trinomial arranged. Big exponent, no exponent, and or I should say the variable term with the big exponent, then no exponent, and finally no variable. That's called descending order based on exponents. A power of 2, a power of 1, and then no power.
So we're going to figure out what can we put in here that we can FOIL out and get this. So what's the second sign in this? Well, right here. Okay, it's a plus. So we're looking at this line. If the second sign is plus, 2 of the first sign. Positive times positive. Notice how I filled those in immediately. If that second sign had been minus, I would have waited to fill it in because there's a plus and a minus, and I'm not sure which one goes first. Now, these first 2 positions have to multiply together to give 3v squared. Well, to get the v squared, we're just going to put a v here and here. But what numbers multiply together to give 3? And when I say numbers, I just mean counting numbers.
Positive integers.
Don't you tell me 1.5 times 2. Yeah, that gives me 3, but I only want counting numbers or positive integers. Well, only 2 numbers I can think of that multiply together to give 3 are 1 and 3. These last 2 positions have to multiply together to give me that last number. Just like right here, negative 7 times negative 3 gave me the positive 21. Positive 5 times positive 9 times negative 5 gives me the negative 45. What numbers, I did the 1 and 3. Y'all do this one. What numbers multiply together to give me 10? Excuse me, 5. Don't say a half times 10. No, just integers.
1 times 5.
1 times 5.
I really like prime numbers popping up in the factoring problems.
So now it's just a matter of you rearranging these numbers to get it to combine to give us that 8v. So I'm going to try 1v times 3v.
Well, that's the only thing you can
That's
try.
the only thing. 1 times 3, does that give me 3v squared if I started FOILing it out? Yes. Now, the tricky part. The 1 and 5. How do I arrange those so I get an 8v for the middle term? Like if I put a 5 right here, suppose I'm going to do this.
Wait.
Oh, okay.
Oh, well, do those pins erase? I think they erase.
I'm going to use one of the. I'm going to use this erasable pen. If I put this 5 times 1, well, 5 times 1 will give me 5. But is that giving us this middle term?
Remember, the outer and the inner have to give you that middle. So what's the outer product? 1v times 1.
1v.
1v.
Okay, 1v. What about the inner?
15.
15. Can I add those? Can I add 1 and 15 together to get an 8? No. So, work. Oh, how? Wow. There. So I'll put let's try the 1 here and the 5 here. Now, Here's how I'm going to do this outer and inner. Okay, we know the first two terms multiply together to give me 3b squared. Do the last terms multiply together to give a positive 5?
Yes.
Yeah. So look at this. This mark I'm making is where I'm writing the outer product. 1b times 5 is 5b. What about this inner here? See these little marks. This big mark is the outer. This mark right here, the inner. 1 times 3v, that's a 3v. Do those add together to give me that middle term? Yes.
You see, if that last sign's a plus, and it is, then you need the outer and inner to add together. 3 plus 5, sure enough, that gives me the 8.
It takes a lot of thought. But there's a way to check these. How do you check it without punching it in? FOIL it out. FOIL this out and see, do we get 3v squared plus 8v plus 5? Well, 1v times 3v, that's sure the 3v squared. The outer, 1v times 5 is 5v. The inner, 1 times 3v is 3v. So are those combining to give the 8v? Yes. What about the last two terms? Positive 1 times positive 5, does that give me a plus 5 here? Yeah. This is called either trial and error or reverse FOIL. Okay? So it can be called both.
We're going to come over here, we're going to type in the factorization. Okay? I don't use the parentheses hot button. If you look closely, you see there's a comma there. That's really for an ordered pair. We haven't gotten to ordered pair graphing yet. When I need a parenthesis, I type it from the keyboard, and it is what? 1b plus 1. I'm not going to even bother typing the coefficient of 1. I'll just write the b plus 1. Remember, if you have a variable and there's no coefficient, it's assumed to be 1. And then I open another set of parentheses, and that was 3v plus 5, close parentheses. And I should tell you, I have people emailing me because they just can't get it right, and they know they're factoring it right because they FOIL it out and they get it right. They're using X. Whatever variable they have in the problem, you've got to use. That's why my law, only allow X's in a single variable environment, only allow the use of X. That would make things better, I think. But
that's your proposed law. Oops, what did I do wrong?
What did you do?
Okay. Now, before we do another one, if you're thinking, oh wow, there's a lot of thought going on. Yeah, there is. And there is trial and error. Here's something that sort of helps rule out some possibilities. If you're factoring correctly, there should be no common factors
other than 1.
There should be no common factor other than 1 in the parentheses. Sometimes you don't say, oh, well, I did it with, and there's a common factor other than 1. Yeah, but that's wrong. Okay.
That's like driving on the left side of the road. It's just not done. It's standard practice for us to drive on the right side. When factoring, it is standard practice not to have common factors inside the parentheses.
But they might wonder, what the heck do you mean by that? I'm going to show you what we mean by that. Like if I had this set of parentheses, 8x minus 10, is there a number other than 1 that divides into both of these numbers?
Yes.
What is it? 2? Okay.
That cannot be right.
And when we say it can't be right, we mean you can't be typing that in as one of the sets of parentheses. If you do, it's wrong. No common factor other than 1.
That means you can't have 2 even numbers in there, those parentheses. And when we start factoring things like 24x squared minus 37x plus 16, where there are a lot of possibilities for the first
And a lot of
last,
even numbers.
and a lot of even numbers, knowing that you can't have two even numbers inside the parentheses really limits out a lot of the possibilities.
Now, what about this? 12x plus 15.
Could that be a correct factorization? Could that be the factor, one of the factors in an answer?
Is there a number other than 1 that divides into both of these? 3? Can't have it. In general, what about 2 of the same number? Suppose I had this. 5x minus 5. Can I have that?
Yes.
Well, wait. What number other than 1 divides into both of these? 5.
You can't have the same number. You can have 1x minus 1. You can have a common factor of 1. You just can't have a common factor other than 1.
Yeah. Now, what about this one? 10x minus 27.
Is that okay? Do they have a common factor other than 1?
It's the only number that divides into both of these. I think it's a 1, right? But 1, 2, 5, 10, none of those numbers divide evenly into 27. So this is the first set of parentheses here that I wrote that you could possibly type in as an answer. Let's try problem number 2. Write it down. Oh.
9x squared minus 3x minus 20.
Oh. Last time I did this. The one from last January was a better example. Did you see? Man, it's a common factor. This time it doesn't. Okay, so here's how I go about getting started. I look at that second sign. I say, okay, the second sign is minus, so there's going to be 1 plus and 1 minus, but wait to fill them in because you don't know where the plus goes. Does it go in the first one or the second one? But I'm just going to make a note. There's a plus and a minus. Now, here's where you've got to know your multiplication tables. Okay? Numbers
Well, we know that x squared is going to be x and x.
Okay, I'll fill that in.
We know that. But for 9, what times what gives you 9?
1 times 9, and there's another pair.
3 times 3.
3 times 3. Now, what about 20? So the pattern, I look and see what numbers multiply together to give you the first number, what numbers multiply together to give you the last number. What all numbers multiply together to give a 20?
I'll get you started. 1 times 20.
Okay.
And then I'll let the class tell me some others. What times what gives 20?
2 times 10.
2 times
2 times
10. And there's one other pair.
Okay. What I do is I start at 1 times itself. Then I start going through. Does 2 go evenly? Yes. Does 3? No. 4? Yes. 5? Hey, 5 is over here on the other side.
I've already listed it.
We've already listed it. We've got them all. If you start thinking through numerically, you can get the list pretty quickly. And now it's
Caution. It's now trial and error. Okay?
We'll try something. When we FOIL it out, if it doesn't give us back 9x squared minus 3x minus 20, we'll try something else.
Generally, unless the number in the middle is a big number, I try the numbers that are closer together first.
Does that always work? No.
Right.
No. But you're having to start somewhere, so we'll try 3x and 3x. If we can't get it to work with 3x and 3x, then we'll go to 1x and 9x. I'm
going to try, okay, let's pair it with the 4 and 5. and see if we can make it work out. In 1992, I had a hostel student. I remember this one day. I was teaching factoring, and I had a hostel student. I never have hostel students anymore, fortunately. And this hostel student said you could feel the anger coming off of him. And either I don't have that anymore or I'm not in tune to it. So if you're sitting there real angry, you're not giving the signs of it, okay? But he said, you're just making this work out. And everyone laughed. And I thought, I got to diffuse this. And I said, wow, that's brilliant. Yes, that's exactly what I'm doing. I'm making this work out. I've got to fill these in so that when I FOIL it out, I get 9x squared minus 3x minus 20. Now, it's been 32 years since then. Who knows what happened to that student? He probably doesn't even realize that I'm still thinking of that student. Every time I do this, I'm making it work out.
Y'all have a preference on which pair? I'll tell you right now, if you really don't know, I try the closest pair.
The pair
pair that, notice 4 and 5, they're close together. There's only a difference of 1. There's a difference of 8. That's a 19 difference. I would think that number there would be bigger if we were going to use 1 and 20, but
if I put a 4, I'm going to try 4 and 5. Nothing guarantees that's going to be the pair that works. Now, how do I know if it works? Well, it's all got to do with this middle term. We know we're getting the 9x squared, and we know we're getting the 20. 4 times 5 is 20. So how do we get this middle term?
Remember, if that last term is a minus, you're going to have to subtract that outer and inner.
So I'm going to draw those marks I showed you earlier. The outer and the inner. The outer, 3x times 5, that's a 15x.
I think we may be getting lucky here. I think we just got lucky.
I think you're right.
It's not a matter of skill, it's just luck. What are we about to get? What's that inner?
12x.
12x. Let's subtract those numbers.
Can those subtract to get a 3? Can I subtract the 15 and 12 to get a 3? Yeah. But what I want is a negative 3x. So I'm now going to start looking at this minus. It needs to be a negative 3x. So there's one plus and one minus that we've already decided. We've decided there's a plus and a minus. How should I arrange them to get a negative 3x? Does 15 need to be negative or 12?
15.
15. So the 15 needs to be negative, the 12 positive. So tracing it backwards, making it work out. What sign goes in front of the 4?
Plus.
A positive.
To get that positive 12x.
And then a minus here. Will that give me the negative 15x?
3 times negative 5. Sure enough, that's a negative 15x.
If we FOILed it out. 3x times 3x is 9x squared. Then the outer is a minus 15x. The inner is a positive 12x. When I combine those, that gives me the negative 3x. And then the last two terms, 4 times negative 5, that's a negative 20. And you know what I want to do? This is such a mess. I'm just going to write down what the answer is that you're going to be typing in. Well, that he'll type in there. Okay? I think it looks better like that than trying to circle this because it's such a mess there already.
I have a question. Suppose we wrote the 3x minus 5 first, and then the 3x plus 4. Suppose I typed this set of parentheses first, and then this one. Would that be okay? If you FOILed it out, would you still get back 9x squared minus 3x minus 20?
No.
I think you would. Multiplication is commutative. A times B is the same thing as B times A, as long as you have exactly the same thing inside the parentheses. 3x minus 5
So here's what you type in. One of these. It doesn't matter which set of parentheses you type first.
Now, it does matter if you put a 3x minus 4 and a 3x plus 5. That would be wrong. But if you have exactly the same thing inside the parentheses, the order of the parentheses doesn't matter.
See, the 3x minus 5 could be typed second or first, as long as it's 3x minus 5, not 3x plus 5. The 3x plus 5 can be written first or second, or typed first or second.
And my lab will accept either one of them. Let's type in the answer. Okay, so we have a parenthesis, 3x. What do you want me to put first? It makes no difference to me. Plus 4 or minus 5?
Plus 4.
Plus 4, close the parenthesis, left parenthesis, 3x minus 5, right parenthesis. Is that what I wanted to type? Oh, a prime number is a number that can't be factored as anything other than 1 and itself. 3 is prime. 1 times 3, that's all that gives you is a product of 3. If the trinomial can't be factored, we use that same terminology. If you went through every possibility, foiling out, and never got 9x squared minus 3x minus 20, that means the thing is prime. But we got it factored. In most cases, they will be factorable. Is there another one you want to do?
I want to show the screen.
Okay.
Can x squared plus 500x plus 1 be factored? If you do what we were doing there, draw your two sets of parentheses. Well, the second sign. Can x squared plus 500x plus 1 be factored the way we did it here?
Well, we know something nice about the signs. Flip over to your table.
Second sign is plus, so 2 of the first sign. So we can fill that in immediately. Plus, plus. There's not a number in front of x squared, so what am I going to put here and here?
X.
X times x. And don't say 2 times a half. What are the only two numbers that multiply to give a 1? 1 times 1. That's the only thing it can be. Have I factored this?
Check the outer and the inner. Are you going to get back a 500x?
What are we getting from the outer and inner? We would get a 1x plus 1x. Is there any way that's going to give us a 500? So this, can it be factored? No. So the option on Pearson, it'll get either, sometimes it'll give you the option just not factorable. Other times it'll say prime. Prime means you can't factor it. You go through all that effort and you just can't get to it. It's numerically impossible. Y'all see, it's impossible to get a 1 here and a 500 there. There's no way. You can't add these numbers together to get a 500.
Okay, let's
try number 4. So here, I'm not just going straight through, I'm just going to be hitting some. Oh, ooh. Okay, 56, what is that, an R squared?
Yes.
Okay. 56R squared plus 31R plus 3.
If it's not factorable, there it is saying the trinomial is not factorable. Depending on who the programmer was that typed the problem to begin with, sometimes they say prime, sometimes they say not factorable.
Back in the olden days when there was one paper book and one person wrote everything, but that's not anymore. Now, a lot of different programmers are writing this. So some people say prime, some people say not factorable. Okay? Okay.
We know something nice about the signs, at least. I don't like that 56, but there's something nice about the signs. What is it? You see, I like to be able to fill those signs in immediately. Well, when that last sign's a minus, you gotta wait. I don't like that, okay? So, but
2 of the first. Fill it in immediately. So I'll put a plus and plus. Oh, gosh. Numbers that multiply together to give 56.
I'll get us started. 1 times 56.
Is 56 divisible by 2? If I divide 56 by 2, what would that give me?
28.
2
28?
times 28.
Okay.
It's not divisible by 3. What about 4? Does 4 divide evenly into 56?
14.
4 times 14, yeah.
5, no. 6, no. 7.
56 divided by 7, what's that?
8.
8.
What comes after 7? 8.
8.
We've got them all. You don't have to check anymore. When you get to that next number 8, we've already got them. We know 9 doesn't divide evenly. Would 12 divide in evenly? No, it's not on the list. Here are the 4 pairs of factors for 56.
Now, what about 3? Only numbers that multiply together to give 3 are, I'll get us started, 1 and 3. Even though this looks terrible, it's not really that bad because there's no other possibility other than 1 and 3. So here's what I'm going to do. I'm going to put the 1 right there and 3 right there. We know 1 times 3. There.
We know the variable part in the first terms, right?
Yeah, an R. I'll go
R.
ahead and put
You
an
can write in
R.
R. But we're going to have to decide, do we want to start with 1 times 56 or 2 times 28 or 4 times 14 or 7 times 8? It's up to you.
7 times 8.
You see, if you're not certain, odds favor starting with the closest pair. That's not always certain, okay? But if you're not sure, try starting with the closest
We just
pair.
make it work out. Can we make it work out?
So that
Play
we can
around
foil
with
it
a
out and get back
7
that
here
original problem.
and an 8 there. Will that work? And if that doesn't, let's try an 8 here and a 7 here. How should I arrange it? If I put the 7 there and 8 there, how do I know if this works? Well,
Check the outer and the
spoil it.
inner.
7R times 8R, that's the 56R square. But what about outer and inner? Is that going to give me a 31? What would I have? 21R and 8R. Is 21R plus 8R, is that giving me a 31R? 21 and 8, that gives me 29. So no.
Try reversing the 7 and the 8.
Yeah.
And if this doesn't work, then we'll back up and try 4 and 14. And if that doesn't work, we'll try 2 and 28. And just keep going until we find the correct combination or we run out of possibilities.
Up here, the outer would be a 24R, and the inner, is that a 7R? If I add those together, does that give me a 31R?
Yes.
Look back at the table to remember. No, where is it? Okay, if that last sign's a plus, you're adding the outer and inner. So
7R plus 24R, that's sure a 31R. We've
there's the
done it.
factorization. Write it out neatly.
8R plus 1 times 7R plus 3.
There's a lot for y'all to think about. Any questions? Y'all are very quiet. Okay, I come over here.
This factoring stuff is something we're going to be doing all semester long. And last week on the first day, I believe Ms. Hovey mentioned that they were doing workshops in the Math Learning Center over factoring. You might have been like, what is that? Well,
oh, I hope it wasn't last week.
well, I don't know
It's
when it
this
was.
week.
I don't know.
Okay.
She mentioned last week. She mentioned that they were
I know, but I don't
going
remember
to do
what she
it.
said.
It was last week.
It was last week?
Oh, well, why would they do that on
Question.
I believe the last one maybe today or tomorrow.
Oh, it
Oh,
is?
okay.
I'm going to look. Before class is over, remind me. I'm going to look. I bet you we got it. You know, something.
No, they do let's do this one here.
Okay.
They'll be doing some factoring more than what we're doing here, but okay. They
Yeah.
should. I think they'll do a factor by grouping and
I got to look.
some other stuff. What we're doing is factoring trinomials. It's try number 5. And this one is illustrating something that my brother was trying to say earlier. Oh, B is another one of those variables.
Looks like a 6.
Okay. Six B squared minus 3 minus 17B. There's a problem with this. What's wrong with it? Well, look at the form it should be in. Okay? There should be a squared term, squared variable, unsquared variable, and then the constant. The constant is what you call a number that doesn't have a variable attached to it. Is this one in the correct form? Squared variable, unsquared variable, constant? No. We need to rewrite this like this. 6B squared, then just write the minus.
Oh, wait.
Oh.
I'm trying to find, I found the email. I knew they sent us an email about the factoring workshop, so I'm finding that.
Oh my
You're
God.
joking.
Way up there, look at that big red sign, Tim. You go get it while I'm doing this.
I knew they sent us it. I was going to find it and print it out.
6B squared, write the minus 17B.
Oh, it is. Today's the last day at 3:30.
Oh.
Let's take a field trip.
But do you see how I rewrote it so that it's like every other one we're doing? When you FOIL stuff out, you get x squared x constant. Well, it's a b. B squared b constant. Make sure you have it written like that before you draw your 2 sets of parentheses. And now that it's written like this, now, wait, you know what? Let me get one of these. I'm going to use the invisible ink and mark out that. I know you can't see it. Yeah, it's invisible ink, okay? Yeah, I know it is. But why am I marking it out? We no longer look at that. The one we're factoring is 6b squared minus 17b minus 3. So what do we know about the signs? Is it going to be plus plus, minus minus, or one of each?
We need a negative product. How do you get a negative product? Plus plus, minus times minus, or one of each? One of each. That, on that table, last sign's minus. So you're going to be using one of each. One plus and one minus. But we got to wait to fill in the chart. Okay. You know what I do when I see one of each? I just guess. Plus in the first one, minus in the next one. I may have to erase it and change it at the end, but...
And I guess that's doable now because of my erasable pens.
Yeah.
Okay, so I'll write out the numbers that multiply together to give 6. 1 times 6, 2 times 3. Write out the numbers that multiply together to give 3. If there's one of them where there's only one pair, go ahead and write those in. 1 times 3.
Normally, I'd say, oh, try the pair that's closest together. 1 times 3. But here's something that I've noticed.
2 times 3.
I mean, 2 times 3. But here's something I've noticed during the
Past 35, 37 years you've been
doing this, okay? Look at the product. 6 times 3 is 18. What's the middle number? If that middle number there is just 1 away from the outer and inner, the first and last product, try the thing with the 1. Do y'all see what I was thinking? I may be wrong, but 6 times 3, that's one of the things I'm checking when I write this down. 56 times 3. Is that just 1 away? Is that 30 or 32? No, so I didn't try 1 and 56. Like what? But here, 6 times 3 is 18. 18's only 1 away from that. So try the thing that uses a 1. It doesn't always work.
But a lot of times it does. So he's suggesting we try the 1 and 6. Now, if we're going to use the 1 and 6, let's go back to something I told you a while ago that you've forgotten. Oh, wait. Remember this statement? No common factor other than 1. Could I put the 6 in this set of parentheses with the 3?
Write the B's.
Oh, okay. My brother says write down the B. Okay. B.
Can he put that 6 in front of that B with that second term being a 3? No, because both of those numbers would then be divisible by 3. So the 6 cannot possibly go there.
So let's try a 6 here and a 1 there. And I'm going to draw my little marks for the outer and inner. So we have a setup. The outer, if you're foiling this out, that 2 outer terms, that would be an 18b.
1 times 1b. What's the inner product? Just a 1b? And now look back at that table again.
Can I subtract those outer and inner terms to get 17? Yes. Okay, how do I arrange the plus and minus? If I want a negative, now I'm looking at that sign, negative 17b. Which one of these, 1 or 18, needs to be negative?
18.
The bigger one needs to have the same sign as the one you're looking. So the 18 needs to be negative, the 1 positive. What goes in front of the 1? Am I going to put a plus or a minus?
Remember, you want a positive 1b. So what's going to go there in front of that 1? Plus or minus?
Plus.
Plus, and then a minus.
So if I FOIL that out, 6b times 1b, 6b squared. Now, the outer and inner, we'd have a minus 18b and a plus 1b. A positive 1b minus 18b, is that giving me a negative 17b?
Yes.
Yes. Now, what about the last 2 terms? Positive 1 times negative 3, is that giving me negative 5?
Negative 3.
I mean negative 3? That's
Yes.
negative 5. Yeah.
So write it out neatly rather than just boxing it in.
Oh gosh, I hope y'all can tell my 6s
From your B's.
I'm not going to write the 1 in front of the 3. If you do,
B.
it'll count it. I mean, in front of the B, it'll count it right. But
Are you sure of that? Have you checked it?
Oh, I
this
haven't
year?
checked it this semester, but
I'm gonna check it. Okay, so 6B. I think I'll write the B minus 3 first, but I'm gonna show the 1 just to make sure that my line, it should accept it, okay? So, and the order of the parentheses doesn't matter. So that's a 1B minus 3. Oh, I'm just gonna put in the 1 there, just to see if they accept it when you show the coefficient of 1. I was literally in calculus classes, and I always showed that coefficient of 1. I may have been in Cal 3 before I quit showing the leading coefficients of 1. And 6B, what was it?
plus 1.
Check answer. Yes. So the order, as long as you have exactly the same thing inside the parentheses, the order in which you type the parentheses doesn't matter. And if you show the leading coefficient of 1, they accept it.
6 or 8. Let's do 8. Okay. Number 8.
We can back up to 6 if you want a minute.
5B squared
Minus
7B
7B.
minus 6. It's another B problem. And of course there's a 6 in it.
Well,
Just like in the other one, there was
on
a
my platform, when I run for ruler of the world, my platform is it'll outlaw the use of these variable B's. Unless, say, you're working on multivariable expressions and you need 26 variables. Okay, you got to use B. Z, I'd outlaw Z. It looks too much like a 2. But I'd outlaw T's because it looks too much like a plus.
S's because they look like 5s.
Mm-hmm.
Okay. So let's draw our 2 sets of parentheses.
Can we just fill in the signs automatically? Is this one of those cases I like where we know what the signs are going to be? No. Last sign's a minus, so what are we going to have inside here?
A plus and a minus.
A plus and a minus. We'll wait to fill those in.
So I'll just make a note right up here, a plus and a minus, so we don't forget. Oh, well, at least there's not a lot of numbers that multiply together to give a 5. What am I about to write here?
1 and 5.
1 and 5. Now, what about 6? There's 1 times 6 or 2 times 3? Okay. Well, since there's only one option here, I'm going to go ahead and write 1B times 5B. Hey, if you don't like that 1, you can just write B. Okay.
No, I don't have any.
Tim's little suggestion. 5 times 6 is 30. So if this was a 29
or 31.
or 31, then we would try this and that. Well, it isn't.
I'm just going to try 2.
I'm going to try 2 and 3. How should I try? Well,
if you don't know, I just put it, the first one I wrote down in the first parentheses, the second one in the second parentheses.
Again, that student, making these work out. That's what you're doing. It's trial and error.
Sometimes you can't make it work out. Remember that x squared plus 500x plus 1.
Yeah.
Can't make it work out. It's prime, but...
So 1b times 3, that's a 3b.
What's the inner product, y'all?
10B.
10b. And now remember that last sign's a minus. So what are we going to have to do to these numbers?
Add them or subtract them?
Subtract.
Last sign's a minus, so you're going to subtract. Can you subtract those numbers so you get a 7?
10 and 3? I think we can subtract those and get a 7.
10 minus 3 is 7. So we just got lucky. This is just a matter of luck. Just a matter of luck that we got it on the first go. But we have to figure out the signs now. Where are we going to put a plus? To get a negative 7b, do we need a positive 10b and a negative 3b? Or do we need a negative 10b and a positive 3b?
Negative 10. Good.
Negative 10 plus 3 gives you a negative 7.
This just takes a lot. Okay, and in order to get that negative 10b, what goes in front of the 2? Negative. Takes a lot of thought.
That's one of the reasons I love these co-recs, because in a regular, traditional, a standalone college algebra class, we don't have time to go through.
Okay, you're supposed to know, remember how to factor. Okay, go on. I mean, I love this class.
Mm-hmm. I remember when they decided, the Texas legislature set up these co-recs, mandated these co-recs. I thought, a lot of my colleagues thought, this is a bad thing. And I remember talking to our former boss, Antonio David, and we were like, it could be a good thing. And I have to say, I think it's a great thing. And I don't agree with everything the Texas legislature does, but this co-rec math classes, and here's the funny thing, the success rate in the developmental math classes, people getting through college algebra, has improved across the state. Okay?
So it's not just Del Mar.
It's not just Del Mar's experience. It's across the state. Hey, question.
I see you put the B on the bottom instead of keeping the B.
It doesn't matter. It's up to you.
It's up to you.
Yes, it's up to me.
You can write 1B or B.
It doesn't matter. I liked showing the ones, okay? But if you view an example, or if you're working with another tutor, they're not going to. They're just going to write B minus 2, right parenthesis, left parenthesis, 5B plus 3. Any questions there? One more number 6.
Okay. Number 6. Okay, let's go back and do number 6. Okay. Yeah. Yeah. This is a good one.
When I said 8 was a good one, I was thinking of 6. I was confused.
6x squared minus 17x plus 2. 6x squared minus 17x minus 2. Plus 2. Now, what do we know about the signs?
Is this one of the ones I like? Can I fill in the signs automatically?
Yes.
Yes. That last sign's a plus. That means you have 2 of the first signs. So minus and minus.
And the way you think this through without just carrying that table around with you all the time is to think, what sort of numbers multiply to give a positive 2?
Positive times positive or negative times negative. And it can't be positive times positive, because when you're foiling, you eventually have to pick up some negative signs.
So it's got to be negative times negative. That's why my little table says if the second sign is plus, 2 of the first. So I'm going to go ahead and fill that in. Minus and minus.
Oh, I like the last. Last times last has to equal 2. There's only one possibility.
I'm going to go ahead and fill
Write
that
it in.
1 and 2. Okay, now 6. Okay, it's either 1 times 6 or 2 times 3.
You can go ahead and write in the x.
Mm-hmm. X here. And here. Well,
unless you have a preference, I'll just start with 2 times 3.
I'm going to try the 2 and 3. Can I put the 2 right here with the other 2? No. There cannot be 2 of the same numbers except 1 and 1.
You could have a 1x minus 1. That's the only way you're going to have the
Can't
same
put the
number
2
inside
there.
the parentheses.
So let's try the 2 here and the 3 there. Are we going to get a minus 17x when we do outer and inner? Let's see. The outer would be a minus 4x and the inner a minus 3x. Am I doing that right?
Right.
I didn't miscopy the problem, did I? This is 17, not 7. Because if it's a 7, we've done it.
Ah, it's a 17. You didn't miscopy
So
it.
these add together to give that minus 17x? No.
So
So
you're going to have to mark it out.
I'm not going to erase. I'm going to just mark it out and start all over.
We still know the minus 1 and the minus 2.
Minus 1, 2.
We discarded the 2 times 3. What's the only other option? We discarded the 2 times 3. So 1 times 6, that's the only other option.
And where does the 6 go? Oh,
Can we put the 6 here? No, because 6 and 2 are both divisible by 2.
So let's try the 6 here and the 1 there. And if this doesn't work, what's the answer going to be?
Prime. This thing is not, if this doesn't work, we've gone through we've exhausted all the other possibilities. Let's see.
When I say work, it means can we get a negative 17x? Well,
I guess we'll be sort of close, but I don't think that's going to be.
the outer would be a negative 12x. And what about the inner?
What's the inner product? Negative 1 times 1x. So 1 and 12 add together to give you 17? So what do we conclude then? Okay, you can't factor it. Either it's not factorable or it's prime. Here they're saying prime.
Oh, okay. Well, I'll write both.
Oh, wait. Let me write that. Let me switch back. You're right. It's prime, which means it's not factorable. So we come down here. We select prime, check answers. In most cases, the things are factorable. I'm always mystified by the people on tests when they go through their 5 factoring problems and they select prime on every one of them. Odds favor that's not going to happen, okay? Maybe it would happen once, but on all 5 of them, no, that'd be a very rare event if it was. Any questions there? Just keeps getting funner and funner, doesn't it? Tony needs to talk now.
Okay, I wanted to show him something. Look back at that problem. In algebra, we talk about equations, and an equation has an equal sign in the original statement of the problem.
With stuff on either side of it, the equal sign.
Is the original problem, is that an equation there on number 6? Say no, there's no equal sign there. Now, as you're working out, you might be putting equal signs, but
the original problem, this is not an equation. To be an equation, it has to be algebraic equals something else, either number or algebraic. Okay.
Click on number 10. I'm going to talk before we do it, but I just want you to see a difference.
There's a fundamental difference in number 10 and the things we've been doing. This is an equation. Algebraic expression, there's those equals bars, and something else on the other side. An equation has an equal sign with stuff on both sides of it. This is an equation. What about number 9? Is number 9 an equation? No, there's no equals such and such. All we're doing is just told to factor. That's what we've been doing. We're now going to change. We're going to have to factor, but that's not going to be our final answer. For these things here, a polynomial expression as the biggest exponent of 2 is said to be quadratic. This is a quadratic equation. The solution to an equation is a set of numbers. It is not a factored form. So, hold on.
Stop talking.
I'm going to stop talking.
See this. Okay, a quadratic equation can be written in the form ax squared plus bx plus c equals 0. And we're going to always prefer the number a to be positive, but I'll show you what happens if it turns out to be negative. If it doesn't pop up today, it'll pop up on Monday. Okay? Mm-hmm. In order for this to actually be a formal definition, we have to make a statement that a can't be 0. You've got to have that x squared. Okay? Do y'all remember in a previous math class, you solved equations that didn't have exponents, and it started with an L. Do y'all remember the name for that? What sort of equation doesn't have an exponent? It just has an x. Starts with L. Linear, that's right. Okay. And so we're going to be reviewing how to solve a linear equation as we're going through here. And the way we're going to solve today, how to solve a QE stands for quadratic equation using our factoring. First thing you do, and hopefully this is already done for you, write the equation in standard form.
That means the square term plus or minus the unsquared variable plus the number equals 0. That's what we mean by standard form.
And hopefully most of the times that'll be done for you.
Let's see. Don't say anything. Look at this is number 10. Is this already in standard form, or are we going to have to change it up? Squared plus the variable plus the constant equals 0. It's already in standard form. For the first one, they're not going to make you have to do a lot of manipulating, okay, for the first equation. But wait a minute. Second step. Factor. Then there's something called the zero factor property. It says that if something times something equals 0, then at one or both of those factors have to be 0. You can't multiply two things together to get 0 unless one of those things you're multiplying is 0. So we set each factor equal to 0 and isolate the variable.
Go through an example.
The big work here will be the second step, factoring. Setting each factor equal to 0 and solving, that shouldn't be too time consuming, but you still got to get the stuff factored. So it's the factoring that's the time consuming part here. On number 10, let me switch it so you can write it down.
5r squared plus 28r
plus 32.
Plus 32 equals 0.
Oh, what's it do?
Notice that the instructions are different for this. It says solve the equation.
Maybe you should write that down.
Okay.
Solve the equation.
Your answer is going to be R equals some number.
Or numbers.
Numbers. Now, everything we've done before here, the instructions said factor.
Factor.
Okay, that's different. When it says factor, your answer is two sets of parentheses. When it says solve an equation, your answer is going to be two numbers. They might both be positive. They might one positive, one negative. They might be fractions. Okay? So,
the way they have it here, they're giving you a hint. They're saying the way they have the answers set up here, R equals. When you're factoring, it doesn't say variable equals. All you're typing are those two sets of parentheses. But when you're solving, they're going to have the variable isolated for you there on the answer portion. So that's your idea. I think they do, yes.
Oh, okay.
Let me see.
A equal. Okay, well then let's get back to number 10.
There it is. B equals.
Okay.
So
write it in standard form. Well, we have an R instead of an X, but it's in standard form. R squared, R constant equals 0. One side has to be 0, and this one is. So let's see. Numbers that multiply together to give 5 is not a lot.
Wait.
Oh.
Okay.
Numbers that multiply together to give 32, there's a lot. What are they?
I'll get us started. 1 times 32, and then 2 times 16. Does 3 divide evenly?
No.
4 goes in
Oh.
evenly. 4 times what? Say 8. 4 times 8 is 32. Does 5 divide in evenly into 32? 6, 7, 8. Hey, we've got 8 already, so we've got all the possible factors of 32.
So I'm going to draw my two sets of parentheses. Hey, I haven't asked y'all about the signs. I'm doing the factoring now. Second sign is plus, so what are we going to have? Positive times positive. 2 of the first, plus and plus. Now there's no other option other than 1 and 5 for 5. So I'm just going to write 1R, I'll just write an R, and a 5R.
Oh, I see it. I see which pair is going to work. Do y'all see it?
They haven't been doing this for...
If you don't know which pair you're going to try first.
Would you try the 1 times 32 or the 4 times 8? Which one do you think? 4 and 8? Do you have a preference where I should try the 4? Let me see. I'm just going to try it like this. 4 and 8.
I think that does it.
The outer plus inner. Is that going to give me a positive 28?
Yes.
Yeah. The inner is a 20R and the outer is 8R. Y'all see that? 8R plus 20R, that's giving me the 28R.
If the instructions had just said factor, we'd box in the 2 sets of parentheses and that's what we would type in. But the instructions said to solve the equation instead. So we have to set each factor equal to 0 and isolate the variable.
So I'm going to take
the only way a product can equal 0 is if one or both of the factors to be 0. So either R plus 4 is equal to 0.
So right now what I'm doing is the new stuff.
This is the new stuff. Let's set number 3. Set the factors equal to 0. Set R plus 4 equal to 0 and
5R plus 8. Now, this is called, what I'm about to do is called solving a linear equation. How do I get this variable by itself?
Subtract 4.
Subtract 4. You're going to do the opposite operation to both sides. This is something when I say this, it's something, okay, yeah, this is something that I'm assuming you've done before in some class. Okay? To solve a linear equation, you do the opposite operation to both sides. So The opposite of adding 4 is subtracting 4. So we get R equals -4. That's the first answer he's going to type in. Now, let's do the same thing right here with 5R plus 8 equals 0. We've got to get the R by itself. Do the opposite operation to both sides, beginning with addition and subtraction. So the opposite of adding 8 is subtracting 8. So we have 5R equals -8. Now, this 5R means 5 times R. What will cancel out multiplication? Divide. The opposite of multiplying by 5 is dividing by 5. Ooh, I think we're going to get a fraction here as our answer. The 5's cancel.
5 divided by 5 is 1, so we just have 1R equals.
And there's nothing I can divide 8 and 5 by, so we just leave that as -8 over 5. Is that visible? -8 over 5 and -4.
So we come over here, and the solutions for R are, I'll put the integer first, okay?
It doesn't matter which one you type first.
I'm just going to type the easier one first. -4, comma, -8 over 5. Any questions there? You know something? Since this is the first quadratic equation we've solved in this class, this is saying if I took -4 and I plugged it in for every R in this problem, what would the left side reduce to? If I plugged in -4 for both of those R's and simplified, what would the left side reduce to?
0.
It better reduce to 0. 5, plug in -4, and let's see, squared. So there's 5 times -4 squared plus 28, plug in -4, and then we still have that plus 32. When I hit enter to get the value, it better be 0. If it isn't, then we've messed up somewhere. Sure enough, it equals 0. We're finding the numbers that when plugged in for the variables will make the left side equal the right side. That's what it means when it says solve an equation. You're trying to find out what numbers can you plug in for the variable to make the left side equal the right side.
What about number 12?
Number 12.
Oh, move
wait
that
a minute.
calculator.
Yeah, I'm going to.
(14c) plus c squared plus 45 equals 0. 14c plus c squared plus 45 equals 0. Okay. Notice it says solve. It doesn't say solve the equation, just solve, but okay.
But notice how the answer's set up. C equals. That's telling you that you're looking for numbers that you can replace C with. You're not going to type 2 sets of parentheses for your final answer. You do that when it says factor. When you're solving, your final answer should be numbers. Okay? I see a big problem with this equation. Is it in standard form? No. What's wrong with it? The squared term must be first. So you're going to write that first. That's a positive c squared. What's this next term going to be? So the plus 14c, I'm using a plus because that's a positive 14.
plus 45 equals 0. I'm now finished with this. I'm going to use my little invisible ink and mark it out.
Don't go back to that original problem.
Just use the c squared plus 14c plus 45.
Some terminology. The coefficient in front of that first term is called the leading coefficient. I don't see a number there. What's the leading coefficient on this? 1. A trinomial that has a leading coefficient of 1 is called a simple trinomial because they're the simplest to factor. Because there's only one possibility. What times what will give you 1?
1.
1 times 1. So this is a simple trinomial here on the left. Now 45, there are some options there. I'll get us started. 1 times 45. Does 2 go in evenly?
No.
3.
I don't realize it, but 3 does. So it's
3
45 divided
times
by 3.
15. Does 4 divide in evenly? No. 5. 5 times 6, 7, 8, 9. We're already back to 9, so that's the list. It seems like most of these have 3 possibilities. I think that's a good number. It's not too bad. What do we know about the signs? We know something very nice about the signs inside the parentheses. Okay.
Second sign is plus, so 2 of the first sign. So I'm going to put plus plus. And the reason this is called simple trinomial is
it's simple to choose the first option. It's just 1c times 1c.
and it's simple to determine the second option. You can just choose it looking at these. If it's a simple trinomial, well, there's no number in front there.
The correct pair is going to either add or subtract to give you that number right there.
In this case, it's going to add. Which pair of numbers adds together to give us that?
5 and 9.
5 and 9. See, so these are the simple trinomials. They're simple to factor. How do you know which ones are simple trinomials? Well, if there's no number in front of the squared term. Okay? Now, we can spoil it out. C times C gives C squared. The outer would be a 9C and the inner a 5C. Does 9 plus 5 give 14? Yeah. What about 5 times 9? Is that giving us this last term 45? Yeah. So have we factored this correctly? Do we type that in? No.
You see, here's what I'm worried about, because it happens. It happens. I see it happening on tests. People will come over here and type those parentheses in, and it's going to count it wrong. You've already done the hard part of the problem, getting it factored, but here they're looking for the solutions, which means you need to solve it on for C. So you
set each one of these equal to 0. And can we isolate the variable pretty easily? What would I do to both sides here to get the C by itself? Subtract 5. So I don't know what other teachers you've had. Sometimes teachers do what I just did right there. Say minus 5, minus 5. So you wind up with C equals a negative 5. And there's your first answer, negative 5.
That's using opposite operations. Some teachers, like I like to just transpose terms.
You'll see teachers do this.
Do it with the
Draw the little arrow. And that means move the 5 over and change its sign. Okay, so it's depending, I'm not sure which teachers you've had and how you've seen it done. Like on this one here, you can go minus 9, or as the things progress, I'll just do this.
Move the 9 over.
Move the 9 over and
change
its sign. Okay? Or you can go -9, -9. Hey, perfect excuse to use my little,
-9.
invisible ink. -9, -9.
Circle your negative
Oh.
numbers. Any questions? Now, the order in which you type them doesn't matter. You can type -9, -5, or you can type -5, -9. But they're showing that you need C to equal, and you separate them with a comma, just like in the previous one. I guess I'll just put the -5, -9. Would take either one. If I type -9, -5, I would still have gotten the same.
Oh, you would have
answer.
gotten it right. Mm-hmm.
Oh,
Number
that's
15.
okay. This is good because it's getting them ready for me. Oh, that's the one I thought it was.
Oh. Wanted
Okay.
it because
Okay.
you need the one with the fractions.
Yeah, but
That's in the next class. Okay. Number 15 on the next assignment is something like this, but instead of 6 and 2, you have some nice fractions like 1/3 and 2/5 or something. But, oh, I should be quiet about that. I tried deliberately not to scare y'all. And you won't, you'll be able to handle it easily by the time you get there at the end of the next class. I just don't know what it is with these 6's and b's. Can y'all tell the difference? 6b squared plus b equals 2.
I used to type it in, start writing it with X's instead. And then with the factorizations, that became a problem because students would try to do the same thing and they type it in with X. Now you got to have it typed in with the B. So whatever variable we're given, we're just stuck with that. I'm not going to change variables. Is this in standard form?
If it's in standard form,
We have 0 on one side, descending order on the other side.
it has to say equals 0.
So is it in standard form?
No, it says equals 2.
There's really only one correct first step. What are we going to have to do?
Got to get a 0 over there. What can we do to both sides to get a 0 where that 2 is? Would I go add 2 to both sides or subtract 2? Subtract 2. So -2, -2, or just my little arrow. I'm just moving this 2 across the equal sign and changing the symbol. Changing it from positive to negative. So here's the equation we're going to be solving. 6b squared plus b minus 2 equals 0. That's in standard form. B squared, b, what do we call a number that doesn't have a variable attached to it? Starts with a C. Constant? Constant equals 0. Theoretically, it could be a coefficient. I believe the
Coefficient.
the Math
of the
371
0.
book calls it a coefficient
For the
also,
0 degree
with
term.
a 0 degree variable, because there's no variable there. But I'm going to call it a constant. Oh, gosh.
Well, it's not that bad.
Numbers
Can
that-
we fill in the signs immediately? On number 12, we were able to fill those signs in immediately. Are we going to be able to do that here? No. That last
Second sign
sign's a
is
minus.
So numbers that multiply together to give 6. There's 1 times 6, 2 times 3. Numbers that multiply together to give 2. That's nice. There's only one pair. 1 times 2.
Write your parentheses.
And I need to go ahead and make a note that there's 1 plus and 1 minus. Second sign, or that last sign, is minus. So the factored form should have 1 plus and 1 minus. What you're saying is numbers that multiply together to give -2 have to be 1 positive, 1 negative.
Hey, let's fill in this number and that number
I
there.
am. I'm going to put a 1 and 2. Why? Well, that's the only possibilities. 1 and 2. Let's see. So what's that little rule you say? 6 times 2 is
12. So if I had a 11 or a 13,
13,
I'd try the 1 and 6 first. But
let's try the 2 and 3. Well,
hey, we know the variable part. Write the variable part down.
B and B. I hope that doesn't look like a 6. Well, the 2 and 3, could I put a 2 right here? No, because you can't have two even numbers, 2 numbers with a common factor other than 1. So you can't have the 2 there. If it's going to factor correctly, it's going to have to be like that. Or else using the 1 and 6, and I don't see that.
Use your bars for the inner and outer. Make your little bars.
I'm going to right now. These are for the outer and inner. First, outer, inner, last. The outer, 2b times 2, what am I going to write here? For the outer, 4b. And the inner, 1 times 3b, 3b. Now, what do I want? I'm thinking of that student that made that brilliant statement. I'm making this work out. And that's what you've got to do. You've got to make it work out. I want a plus b for my middle term. Why don't I go ahead and put the number in front of the b? That's going to be a plus 1. Can I subtract these numbers to get a 1? Yes. If I'm going to get a positive 1, the bigger number needs to be positive. Smaller one. Negative 3b plus 4b, would that give me a positive 1b?
Yes.
So how would I make it? How am I going to put the plus and minus? What goes in front of the 1?
Negative.
A negative in front of the 1.
Negative 1 times 3 gave us the negative 3. Positive 2 times a positive 2 gave us the positive 4b. Are we through with the problem? No, we got to take each set of parentheses, set it equal to 0. Push that.
Oh. Move this up. So how do I isolate these variables? How do I get this b by itself? What do I do first? The opposite of subtracting 1 would be adding 1. So we just have 2b equals 1. And this 2b is 2 times b. So the opposite of times is? So divide by 2. And it looks like we're getting a fraction for our first answer, 1 over 2. Or 1/2, whatever you want to call it. Can we do the same steps over here? What do we do first? We subtract the 2. Oh, I did it without, this is my habit. Okay, without even thinking, I drew the little arrow.
Move
the
it over,
2 over,
change the
change
positive
the
2
sign.
to negative 2.
So we have just a 3b equals negative 2. And then what? Divide by 3. So what we're doing here, we're taking a quadratic equation, rewriting it as 2 linear equations. Oh, well, let me do this. B equals negative 2 over 3.
I think this is the first time we've typed 2 fractions as answers, so be careful. Right. Okay, so we have 1/2 1 over 2.
Oh, also, you're going to put a comma now. Do not put the comma in the bottom of the fraction.
What I just did
But
there.
can y'all see what he's done there? The comma's in the bottom. Now continue typing. Type the negative 2 over 3.
Negative 2 over 3.
Is that what he's supposed to be typing? No, no, no. Get rid of that comma.
Move out of the denominator. Either do a right arrow, click with your mouse, do whatever it takes to get out of the denominator. Then you put your comma, and then it's what? Negative 2 over 3.
Typing in two fractions like that can be a little tricky. You make sure your comma's in between the fractions, not in the bottom of the denominator of the fraction.
And I'll warn you right now, some of the programmers went through and thought, oh, I'm going to be nice, and they changed the programming so if you had the comma down there in the denominator, that's fine. They would accept it. Other programmers didn't do that, so sometimes you could work this problem and maybe it would take it with the comma in the denominator. But that is an incredibly bad practice because we're going to be getting to interval notation and solving nonlinear inequalities soon. And if you put a comma in the denominator, it's a long problem.
I can't think of a time you should ever type a comma in the denominator of a fraction.
Never. So get out of that denominator before you type the fraction, the comma, even if maybe for one particular problem it lets you do that. In the upcoming assignments, it's just going to be marking the stuff wrong. So,
okay. Any questions?
We've done a lot of good stuff today.
It takes a lot of thought. And if you think with this factoring, you're making it work out. I know that sounds strange. That student 30-something years ago, he meant it as a bad statement, but that's what you're doing. You're figuring out the numbers that'll make it work out. Oh, Tim.
I didn't open that.
But I did it as a student. Okay. Okay, well, if you have any questions, let us know.
Also, if you have your computer and you're having trouble downloading the software, and I hate to say this, try on the tablet, try on your iPad, go and see if it'll let you download that software, okay? Go to the sample test, at the bottom of the screen, say download, okay? Oh, I better stop recording, hadn't I? Oops. Hold on.
See.
Oh,
Just click like that.
I missed it.